In a universe filled with billions of galaxies, each galaxy holding billions of stars, and each star possibly surrounded by dozens of planets, we are nothing but a tiny, lost point in this endless vastness. In the face of the universe's grandeur, we are insignificant, but gazing at the stars always sparks one profound question. Are we truly alone? And where exactly is our place in all of this? Let's embark on this grand journey together, somewhere among the stars in search of answers. You can think of the solar system as a big family where the sun plays the role of the center and the leader of this family. The sun is a giant ball of hot gases that provides light and warmth to all other members of the system. The sun makes up more than 99% of the entire mass of the solar system, and everything orbits around it thanks to its gravitational pull. So, who are the members of this family? The solar system has 8 planets that revolve around the sun in almost elliptical orbits. These planets are divided into 2 categories: rocky planets like Mercury, Venus, Earth, and Mars, which are smaller with solid surfaces, and gas giants like Jupiter, Saturn, Uranus, and Neptune, which are much larger and mostly made of gas. Now, within this vastness and sheer beauty, where exactly do we stand? Earth is the 3rd planet closest to the Sun. The distance between Earth and the Sun is approximately 150 million kilometers. Scientists have a special name for this distance: 1 astronomical unit, AU. This unit is also used to measure other distances within the solar system. How did we figure out that the Earth is located here? One of the first methods was observing shadows and the angles of sunlight. For example, if you stick a straight stick into the ground and measure its shadow at 2 different points, you can figure out how far Earth is from the Sun with some math. This was something a Greek scientist named Eratosthenes did. By measuring the shadow in 2 different cities, he calculated the Earth's radius, and from that, he estimated the distance from Earth to the Sun. Later, scientists used special events called planetary transits. When the planet Venus passes in front of the Sun, you can calculate the exact distance from Earth to the Sun by measuring the precise time of the transit and the angular distance between Venus and the Sun. This was a form of triangulation. When you want to know the distance between 2 points, all you need to know is how far apart they are in your line of sight. However, old methods weren't very precise. When humans were able to send radio waves into space, the world of astronomy changed. Scientists sent radio waves toward nearby planets like Venus and Mars. When the waves reached those planets and bounced back, by measuring the time it took for the return, they could calculate the exact distance from Earth to those planets. Then, using this information and the planetary motion laws discovered by Johannes Kepler, they determined the distance from Earth to the Sun and the precise orbit of Earth. After this, when spacecraft like Voyager were launched into space, we obtained more precise information about the position of Earth and the other planets. These spacecraft, by sending signals back to Earth, helped us better understand the solar system. Voyager 1 has now left the solar system, but it still sends information, and scientists can use this data to determine where we are in the solar system, and even in the galaxy. Now that we've understood where Earth is in the solar system, and what factors have made this position ready for life, let's step away from our solar system and see where we are in the universe. The Milky Way is a barred spiral galaxy with an estimated diameter of about 100,000 light-years, containing between 200 to 400 billion stars. This galaxy consists of several sections, each playing a vital role in its overall structure. The galactic core contains a dense region of stars and a supermassive black hole known as Sagittarius A, which has a mass approximately 4 million times that of the Sun. We live in one of these spiral arms, the Orion Arm, also known as the local spur, a smaller structure situated between the galaxy's larger arms. Our position in this arm is about 27,000 light-years away from the galactic center, located in a relatively calm and stable region. This distance keeps us away from the disturbances of the galaxy's central region, where a high density of stars, hot gas eruptions, and the gravitational effects of the supermassive black hole prevail. This stable environment has been crucial for the formation and evolution of life on Earth. We step back a bit and reach the local group of galaxies. The Milky Way is not floating alone in space. It is part of the local group, a collection containing more than 50 galaxies. The local group spans approximately 10 million light-years and behaves like a small galactic cluster under the gravitational influence of its members. The local group is just one component of a larger structure known as the Virgo supercluster. This supercluster consists of around 100 groups and clusters of galaxies spread across a region approximately 110 million light-years wide. At the heart of this supercluster lies the Virgo cluster, located about 53 million light-years away from us and containing over 1,000 galaxies. The Milky Way and Andromeda galaxies are slowly moving toward this cluster. In the end, all these colossal structures are merely parts of what we call home. We, tiny travelers of this boundless universe, reside in a corner of the Laniakea supercluster, a structure resembling a galactic stream that contains over 100,000 galaxies. With an expanse of more than 520 million light-years, it is akin to an enormous cosmic ocean, where our Milky Way galaxy is but a small ripple on its surface. Yet even this colossal supercluster is nothing but an insignificant dot compared to what lies beyond on cosmic scales. This structure is merely one of countless superclusters scattered throughout the observable universe, like islands dispersed within the vast fabric of the cosmos. We are part of this cosmic architecture within a universe that spans at least 93 billion light-years in diameter and continues to expand. Every galaxy, every star, every planet, and even every atom within us is composed of particles that once burned within the hearts of massive stars and were then scattered across space in a cataclysmic explosion. Beyond the boundaries of the observable universe, a secret lies hidden, a place where light has never reached us, and perhaps the answers to our greatest questions are concealed within that endless darkness.